Composite is a structural design pattern that lets you compose objects into 3 structures and then work with these structures as if they were individual objects. In our live example, the structure is like a construction site where comments are passed down from the top clients through vice presidents to managers, so-called nodes, down to the construction workers that will actually do the job. In Java example, we will build graphical interface shapes editor based on a Swing library. First, we have to define our common interface shape. For nodes, containers, and leaves, the objects themselves. Second, we implement abstract class based on this interface with a standard set of fields like location, x, y, color, selected, etc. with getters and setters. Here we will also define methods that have references to the graphics themselves. We cast it to graphic 2D to have control over geometry, and by setting new stroke with new color we can mark this object as selected and deselected it by adding basic stroke. Now we can create a concrete class, in this case a simple circle that extends base shape. Here, besides invoking parents methods, we have to define radius with overwritten methods to calculate width, height, and to paint it on the canvas. To do the latter, we have to invoke drawOval method on a canvas reference with location and radius for height and width. Our next component will be a rectangle. We define it pretty much the same way, with the exception that this time we need 2 additional parameters, which are width and height. Besides, we have to invoke drawRect method on the canvas reference with location, width and height. We subtract 1 because point itself has 1 pixel width and height. After those 2 example shapes, we will define a clue of this design pattern. A compound shape that behaves like a regular shape also inherits from base shape but delegate all the actions to the nested elements. This component is like a node in our tree-like structure. It defines all the methods that are for managing nested objects like adding and removing from the list. But also has to override methods from base shape, so to calculate x location it loops through the list to find the smallest number which is the highest on the canvas. For width we will add location to width to find the highest number which is the bottom of our canvas. To select all the elements we draw rectangle around them, and for painting we just invoke paint method on each one of them. We are adding 1 to width and height and subtract from location to not let overlap with the elements. The main brain of this program will be image editor class that will create a canvas based on an inner class and load all the elements into it. Our inner class extends canvas class from Swing library, and thanks to it we'll have access to the main panel in our custom elements defined previously. This class creates a main frame and attach it to itself, and also sets mouse event listeners to handle selecting elements. You have to remember that with every change we have to invoke repaint method to reproduce the latest changes. Thanks to all of these abstractions, client code is stunningly simple. All we have to do is to create image editor object and load all defined previously shapes with unlimited nesting possibilities. If you found this video useful, follow for more educational content like this one.